Okay, a very good day to everybody. Today, our group like to present the subtopic 3.4, which is electromotive force (EMF), internal resistance, and potential difference. Okay, dalam subtopik ini kita akan belajar sebenarnya apa yang berlaku dalam bateri ataupun sel. Okay, first we consider a circuit that consists of a battery or cell that is connected by wires to an external resistor. Okay, this capital letter R represent the external resistor, while this small letter r represent internal resistance, while this is EMF symbol. Okay, this is battery or dry cell. Okay, this circuit is connected in series. Okay, before we study what is happen when current flows or when current is not flow, we have to know what is mean by EMF. Okay, EMF or electromotive force is the energy provided by the source battery or cell. Tenaga yang dibekalkan oleh battery atau sel to each unit charge that flows the external and internal resistance. Okay, maksudnya tenaga yang dibekalkan oleh bateri untuk setiap unit charge yang flow through the external resistor and internal resistance. By the way, but the EMF is not a force. EMF itu bukan satu daya. It is a special type of potential difference. Dia satu type of potential difference. So unit bagi EMF bukan Newton. It's not a Newton, while the unit for EMF is volt. Okay. Another term that used in this subtopic is terminal potential difference or voltage. Okay, yang ni dimaksudkan the work done in bringing a unit test charge from the negative to positive terminal of the battery through the external resistor only. Kerja dilakukan untuk membawa satu unit test charge dari negative terminal of the battery to the positive terminal of the battery. Ini positive, negative, and to the external resistor. Only involve external resistor. Okay, the next is equation only applicable where we use dry cell or wet cell. Any cell, battery, dry cell or wet cell, there is an internal resistance which we can use this equation. But we use power supply, we cannot use this equation to calculate the terminal voltage. So we have to remember that the battery or dry cell or wet cell only have internal resistance, not power supply. So the unit for the both EMF and voltage are volt. Okay. Okay, moving to next slide. Okay. First we see this circuit. Okay. Dalam circuit ni switch itu not switched on, so this is switched off, so there is no current in this circuit. Switch is not turned on, so there is no current flowing in this circuit. So the EMF is equals to 3 volt, and this will same. So the voltmeter reads also same, which is 3 volt, because terminal voltage is equals to EMF only if there is no current flowing. Okay, tapi bila ada current flowing, because the switch is turned on, so there is a current flowing in this circuit. So the EMF is 3 volt, but the voltmeter read shows 2.25 volt, lesser than the EMF. Okay, this show the internal resistance of the voltage source affect the output voltage when a current flows in this circuit. So this shows that there is an the internal drop in potential difference in this circuit.
Okay, so the next is internal resistance. Internal resistance is defined as the resistance of the chemicals inside the battery between the poles. The smaller the internal resistance for a given electromotive process, the more current and the more power the source can supply. Internal resistance can behave in complex way. As noted, internal resistance increases as the battery is depleted and electrolyte rise out. But internal resistance also depends on magnitude and direction of the current through a voltage sources, its temperature and type of chemical material. The internal resistance of the rechargeable cadmium cell, for example, depends on how many times and how deeply they have depleted.
Example question for subtopic 3.4, number 5. A 12-volt battery has an internal resistance of 1.5 ohm. It is connected to a 6.0 ohm resistor. So we have V equal to 12 volt, while the resistance equal to 1.5 ohm. And lastly, the resistor R equal to 6.0 ohm. So, to answer the question 5A, what is the current in the circuit? To calculate the current in the circuit, we should use the equation E equal to I R plus resistance. So we know the energy is 12 volt. So we want to find the current. So the resistor is 6.0 plus 1.5. So we can get the current of the circuit. Ampere. So the answer is the current in the circuit is 1.6 ampere. The next question is, what is the terminal voltage of the battery? To find the terminal voltage, we can use the equation of V equal to IR. We want to find the voltage. So the current we have already find at the question A, 1.6, and the resistor is 6.0. So the voltage is 9.6 volt.